Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of projections. So as per the problem, what are the scalar and vector projections of m parentheses negative 1, 2, 4 on each of the three axes? So we have to calculate the scalar and vector projections of this vector, and this vector is given in the form of a scalar m being multiplied to vector negative 1, 2, 4. So we can multiply each component in this vector by this scalar m, and we can rewrite this vector. So we multiply each component by m. Now we can write the vector for each of the three axes. So let's start with x-axis. For x-axis, the vector can be the position vector of any point that lies on the x-axis. So we can use the easiest point 1, 0, 0. So the vector for x-axis can be the length of this vector won't matter because the projection value is not dependent on the length of the vector on which the projection is calculated. So there's a very important concept we need to understand and memorize. For y-axis, we can use the vector 0, 1, 0, and for z-axis, we can use the vector 0, 0, 1. Now we can find the scalar and vector projections. So let's start with x-axis. So I'll write SP for scalar projection. So we can use the formula. So A represents the given vector, x is the vector for x-axis. In the denominator, we can calculate the magnitude of vector x. So we should square the components, add them, and apply square root to the sum. Now we can do the dot product in the numerator. Negative m times 1 is equal to negative m. 2m times 0 is 0. 4m times 0 is 0. And the denominator is equal to 1. So the answer is just negative m. So that's the scalar projection of the given vector on x-axis. Now we can calculate the vector projection on x-axis, and I'll use VP for vector projection. So the dot product we calculated in this scalar projection as negative m. The magnitude of vector x is 1. Now we can multiply the vector 1, 0, 0 by negative m. So we have to multiply each component by negative m, and we get, so this is the vector projection of the given vector on x-axis. Now we can do the analysis for y-axis. So vector y is the vector for y-axis. Now we can do the dot product in the numerator. So I got 2m for scalar projection on y-axis. Now we can calculate the vector projection. So for the dot product in the numerator, we got 2m. The magnitude of y is 1. Now we can continue here on the top. So we can multiply vector 0, 1, 0 by 2m. So we'll multiply each component by 2m and we get. So this is the vector projection of the given vector on y-axis. Now we can do the analysis for z-axis. Now we can do the dot product in the numerator. So we get. So the scalar projection is equal to 4m. Now we can calculate the vector projection. The dot product in the numerator will give us 4m. The magnitude of vector z is 1. Now we can multiply the vector 0, 0, 1 by 4m. So we multiply each component by 4m and the answer is. So this is the vector projection of the given vector on z-axis. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.